Hi guys. We're on our second day of solving using the quadratic formula. Yesterday we went over two types of answers that we could get. One was we got rational roots, which was like nice numbers, it was like whole numbers or decent fractions, like 5/2 or something like that. And then the second type of answer that we got were irrational answers. So answers where there's still a square root sign as part of the answer. We were not able to square root the number completely. So today we'll be going over the last two types of answers that you can get, which is imaginary and then a double root. So that'll be every type of answer you can get when solving using quadratic formula. Here is our first example. The first thing you should do when you're solving using quadratic formula is make sure that your equation is set equal to 0. This equation is not. Now, I like to keep the y squared term positive, and so I will not be moving the 5y squared to the other side because I just like it when it's positive. It looks more normal to me. So I'm going to take the 6y and subtract it to the other side, and I'm going to take the -3 and I'm going to add it to the other side. And so this is my new equation. And now that it's equal to 0, now I can use quadratic formula. I find it helpful to write down what the A, B, and C are so that when I'm saying the quadratic formula in my head, right, like I can look and clearly see what A, B, and C are. So in this problem, my A is 5, my B is -6, and my C is 3. Notice how the B and the C have different signs than if we had not changed the equation. So very important that we had changed it. Today, if you want to, instead of saying the story, we can sing the song. Now, this problem we're solving for y, so normally we say x is equal to, but like today it's going to be y is equal to, okay? So, y is equal to -b plus or minus square root b squared minus 4ac all over 2a. One thing I want to point out, I went ahead when I said -b, since b was already negative, and I know the opposite of a negative is a positive, I went ahead and already wrote this as a +6. So yesterday I wrote it as a double negative. Today I just simplified it in my head. And it is technically the opposite of -6, okay? Also want to point out that when I plugged my b into the radical and did the b squared, that I put it in a parentheses. This is, again, going to be very, very important, especially if you're relying on your calculator to do all of your calculations for you. So make sure that you are getting into the habit of typing in negative numbers surrounded by parentheses with any of your calculations on the outside of the parentheses. But we can totally do this part in our head, right? -6 squared, that's -6 times -6, that's +36. And then 4 times 5 is 20, and 20 times 3 is 60. I also simplified the bottom. I did 2 times 5 and got 10. Next, I'll be doing this 36 minus this 60, and I got -24. Now, again, it is possible for you to skip straight from this step down to this step. Just make sure that you're typing the part underneath the square root sign in accurately onto your calculator with those parentheses. Also, do not type the square root symbol, just type the underneath part. Now I'm going to stop for a hot second right here. And I've got the part underneath the square root is a single number. And so since it's a single number, I am going to go ahead and state my discriminant. And that's going to help me figure out like what kind of answers I'm expecting to see on this problem. So the single number underneath the square root sign, -24, is my discriminant. And we learned on Wednesday's video that if my discriminant is a negative number, then I'm going to expect to get 2 imaginary roots. Now, hopefully with this example, it makes sense why we are going to get 2 imaginary roots when the number is negative. And it's because we're doing the square root of a negative, and that's like the definition of imaginary numbers. In fact, for my next step, I'm going to go ahead and take this negative symbol. I'm going to hop it outside the radical sign, and I'm going to turn it into the letter I. Okay, so remember, when the negative goes to the outside, it turns into a letter I, and then there's no longer a negative on the inside. From here, my next step is to do a factor tree on my 24 to see if I can get anything like out of the radical. So I'm going to do that up here because I don't have enough space down there to do that. So it's 2 and 12, which is 2 and 6, which is 2 and 3. And you can see right here, I have a pair of 2s. So one will go out, the other one is poof, gone. And then this 2 and this 3 will multiply back together to give me a 6 under the radical. Now the 2 that went out, it's going to go out and it's going to stay right in front of the radical. So the I is right in front of the radical and the 2 is right in front of the radical. You don't want to accidentally like go too far over and like put it with the 6. So don't pass that plus or minus sign. Keep all the things from the radical like held together after the plus or minus sign. Once you've simplified your radical, now you can check and see if you can simplify your fraction. To simplify the fraction, you need to look at your 3 outside numbers. There will always be 3 outside numbers, one in front of the plus or minus sign, one after the plus or minus sign, and then your denominator. If there are not 3 outside numbers, if one of them is missing, then you can't simplify. And all 3 of the outside numbers need to be divisible by the same thing for you to be able to simplify. It's all or nothing. They all get divided or none of them do. In this problem, I can simplify because the 6, the 2, and the 10 are all divisible by 2. So I'm going to take all my outside numbers, not my inside number, and I'm going to divide by 2. And I get this new fraction. Now, if we were in class and we were doing everything on paper, I would say like, there you go, that's your answer, type that in. And in fact, on tonight's worksheet homework, this is a totally acceptable answer. Like, go ahead and just leave it like that. I'm fine with that. Delta math, on the other hand, has a different idea of what the answer should look like. So again, this is totally acceptable for paper homework. It's acceptable for quizzes. Honestly, since I'm going to be hand grading your Delta Math test, this would be acceptable on a Delta Math test. But for your Delta Math homework, which I do not hand grade, Delta Math is looking for your answers to be in what is called complex number form. Complex number form is A plus BI, which means that Delta Math wants an answer that is the real part, the part that does not have an I with it. And then completely separate from that, it wants an answer that is the imaginary part, and it wants the letter I at the end. So basically what we're going to do is we're going to take this and we're going to split it into 2 separate fractions. We're going to split it where the plus or minus sign is. And because it wants the I at the end, we're going to take the I and we're going to put it after the second fraction. Don't put it as part of the second fraction, put it completely after. So when you're typing this into Delta Math, it should look like this. This is an appropriate answer for Delta Math. So I have my real part, which is 3 over 5. And then completely separate from the fractions, I have my plus or minus sign in the middle. And then I have my imaginary part, which is the square root of 6 over 5. And then the I is after the fraction. So again, make sure that you're typing it in after the fraction. And this is how you should be typing in your answers for your Delta Math tonight. All right, so that was the scenario where the answers were imaginary. And again, I do want you to write an imaginary answer. It is no longer appropriate to say that there are no solutions when you're square rooting a negative. Now that we know that imaginary numbers exist, we have to use them as our answers. Now there's one last scenario that we haven't talked about yet, so let's do that one. In this problem, my equation is already equal to 0, so I don't need to change anything. I can go ahead and find my A, B, and C right now. In this problem, A is 4, B is 20, and C is 25. Let's sing today. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. You can like hum it to yourself while you're writing in the numbers, right? All right, let's do some simplifying. So 20 squared is 400, and if you don't know that, type it into your calculator. When I'm multiplying the second one, I like to do 4 times 25 first because that's 100, and then it's easier to multiply 100 times 4. So 100 times 4 is also 400. And then don't forget to multiply the bottom numbers. 2 times 4 is 8. Next, I'll do 400 minus 400, and that is 0. Now that I have the part underneath the radical as a single number, I am going to say my discriminant. My discriminant for this problem is the number 0. And we learned on Wednesday that when your discriminant is equal to the number 0, that means you will have one real double root. That means that when I'm done with this problem, I'll get the same answer twice, but I'm only going to write it once. I'm going to put the words dr after it. The reason why we only get one answer is the square root of 0 is 0. And negative 20 plus 0 is negative 20. And negative 20 minus 0 is also negative 20. So adding 0 and subtracting 0 will give us the same answer. And so if you have a 0 after the plus or minus sign, if your 0 was the discriminant, then you're just going to get one single answer and you only write it once. I am going to simplify this fraction. Remember, no decimals this chapter. It's a simplified fraction. And for our paper homework, I do want you to write the letters dr after it. For your Delta Math, you do not need to write dr. So paper homework, I would like to see the letters dr so that I know that you know it's a double root. And on Delta Math, you'll just need to type in the answer once. This concludes our notes about the quadratic formula.